Well, after many weeks, I'm back again to work on the scrolling marquee sign. Where we left off was this clock oscillator circuit. I'm going to just sort of reverse engineer it quick, then remove it since I'm not using the original processor, so my new microcontroller will have its own oscillator and related support circuitry, so as long as this doesn't feed back to somewhere else in here, it's sort of extras. That's the reset circuit. Pen circuit. Stick it right on that page. You need a pen. Pen. And a new back. So, the easiest point to start reverse engineering it is at the crystal, because it's the most obvious part. I'm guessing this is a 4 meg crystal based on the 4.000 on there. This connection right here was just mostly, that I've already removed, was mostly just for mechanical support. It also grounds the case of the crystal to reduce some noise. It's typically not always needed. So it comes in and hits the center two resistors. Yes. So brown, black, red comes in, goes 1Ks. It's going to be fun to debug. It also goes somewhere else. Other side of the 1Ks, one goes to a cap. We'll just start with this top one. Goes to a cap to the other 1K. Looks like it. Yep. Ceramic. Okay. That was that cap. And both of these run 1, 2. So that is pin 7404. Pin 1's on that end. So 1, 2, 3, 4, 5, and 6. Let's see what 5 and 6 of 7404 is. Oh my. I'm guessing this is an inverter, just from the little bit I know of crystal theory. That is a hex inverter. Okay. A to Y. I'm slow computer. So A is the input, Y is the output. So pin 5 is the input, 6 is the output, I think. Yeah, A is the input. 5 is the input. So back to this. So pin 5. Which is So the input is going to the top. Right? 5. Okay, so that's going to the input of an inverter. And then the output. Ooh, that was unexpected. Goes back to that side of that resistor. It also hits, I think it's a brown, black, brown, 100 ohm. Which goes to this via through. Smack dab underneath it. Looks like it goes to that cap there. And then goes to a 7474 pin 3. I think that's the ground. Yep, ground. So what's 7474 pin 3? Oh, it's a flip-flop. So it's a dual flip-flop. Pin 3 is clock. Via connection 1, 2, 3. 74 LS 74. Okay, so now let's finish tracing the bottom one. So the bottom one, that connection. It's really hard to see if this is actually connected there or not. Let me grab that meter. Did not mean to step on that. So, first question, are these connected? Nope, those are not connected. Are these connected? Those are connected. So, resistor to cap, which we already have, 1, 2, 3 down. 1, 2, 3. Okay. Comes over here. Pin 4. Pin 4 is an output. Pin 3 is the input to that. I think that's another ceramic type cap, but not totally sure. Yeah, it only has 2 pins, so it's not a resonator. And it hooks to ground. So let's say cap to ground. And then it also goes to this. Yeah, poor drawing. So crystal and resistors with feedback on them. So apparently this must look at the current sort of floating back and forth here to turn on and off these inverters. Which then redrives it. Ooh, this inverter drives stuff up here, so I can't pull him quite yet. But I can pull crystal, cap, resistors. You know, sort of clean out this hole so I can get in there and look at that flip-flop a little better. Turn this thing. Yeah. All that's warming up. So this is definitely a flip-flop. Let's see where... the other signals of this inverter go. Reset circuit, I bet. Yeah, U9 pin 9. 2, 3, 4, 5, 6. Yeah. And the inverter output. Go to that via. Oops, around right there. Runs along the bottom here. Goes to that via there. Whatever U6 used to be. Yeah, U6. It was a reset into the UART. So that makes sense. It was probably active low versus active high. So we got the center two here. I don't know why. Oh, I'm making the assumption these traces go all the way underneath it up to there. They may not. Let's check that now. Huh, they do. Oh, I bet you then they flip up to here. Which they do. Right there. You're 13. Well, U13's gone, and it's not obvious from my notes what it was for, but that at the very least tells me those connections on here are not required. So some signal came in, got inverted, sent down, got inverted again, sent down. That takes care of the top half of this chip. is the most significant pin off of this processor. Let's go look it up and see if the description of that pin tells me anything. Oh, soldering iron's hot. What is this guy, like a 40? Oh, it's an address line. The most significant bit of the address line. Not fully sure. You know, it makes sense they double invert. They're double inverting to drive the longer net. So, you know, one inversion to get it inverted, drive the long net. Second inversion to put it back to normal, but give them the driver to the long net without having to put another chip on here. The fact that it's the most significant address line, well, it's not. It's address 10. It's a high order address line. It's probably some sort of bank select, you know, where one of those two lines went and drove all the memory logic versus, you know, ROM logic. I thought I had traced all that out at one point in time, but, you know, since then shit gets lost. Either way, it doesn't affect what I'm going to do, so it doesn't really matter. It's just more of, I can say, okay, this portion's not used anymore, that portion's not used anymore. So I'm down to the portion on this side. Two of these are the are these two inverters that run the oscillator, or crystal, which is going to be going away, so they don't matter. So that leaves me two gates. The first two gates on this part, which I don't see a connection to. More than likely they're not used, but I'll be careful when I solder suck that off because I may have to put it back on. Oop. One 4 meg crystal. Bin of parts. And all these parts can go away too.